Out again. The first 7 of these panels have a sort of bluish tinge to them, and if you look back at the first couple where the illumination is better for us, you can see the pattern of the polycrystalline silicon collectors which are there, much as the panel we have here, the demonstration panel, to produce the power which goes into our accumulated supply. The solar panels there, just those first 7, produce electricity as well as producing heat. The remaining 15 panels to the right of that, slightly browner ones, are more conventional solar thermal panels with no electrical generation. Those hybrid ones were built on an experimental basis, fairly complicated to build and rather costly to produce. They work, but they at the moment are not, we think, in a situation where we really want to see them go into production just yet. There's some issues about how to get them best construction, because photovoltaics work best if they're kept cool. Solar thermal systems work best at high temperature, so the two are somewhat in opposition, and you've got the extra fabrication costs and complexity of control, which is not insurmountable, but we don't think it's at a level yet that we see it being right for the general commercial market. So we're still gaining experience and monitoring how those are performing. But essentially that's our bank. I think I'm right in saying it's the largest bank of solar thermal collection in Europe. Obviously things change, it may not still be true, but it was when it was first put up there. Obviously the position in which they're mounted, it was set up to give us the 30-degree pitch that we wanted to get maximum benefit of the angle of the sun. And we've done that by putting it on the roof of a building which you may have seen as we walked up is called the Crop Store. We built that by taking the excavated material from this site. This car park is at a bit lower level than the land behind the turbine. If you look, you can see we've taken out about 4 metres or so in depth there just to make this flatter. And accumulated soil was stored on the site to make the hill behind the crop store there, which gave us the height then to get the pitch on the roof of this. And inside, underneath there, was the storage space to store all the miscanthus grass once it's been cropped and baled up. So it's a fairly integrated process that's been developed here, even though we're reviewing exactly how we want to use it. I haven't got the train running at the moment. We often get, when the kids come around, we get the train running around there to get them familiar with the idea of solar power. But it's fun to do, but we've had some politicians around here who've seen it, and I often wonder if that's the only real memory they took away with it. Okay. Visual anyway. Right, here's the turbine. It is.
Or you could just hear that.
Yeah.
That swoosh.
I don't need to make my normal joke about having to shout above the noise of the turbine. If you strain your ears, you might just hear it swoosh, yeah, separate from the noise of the motorway. But such contrasting noises.
But it's not really noise.
No, it's a sound. The noise is not the right word for it. It's a sound. You're right, and you have to listen carefully. Can you all hear it? You have to strain it. It's a swooshing noise. It's not, to my mind, it's not really very unpleasant anyway. But that's all we're talking about. When people talk about turbine noise, it's that, perhaps at a higher level and more of it, but it's not a different character of noise. It's that sort of noise. So bear that in mind when you hear people complaining about the intolerable noise of a wind farm. You think, okay. Right, this is a fairly old unit. It stands 36 metres up to the hub. The rotor diameter is 29 metres. I was telling you inside, I think the charts were showing us that we're now building turbines up to 90 or even 100 metres in height. So 2.5 times this, getting on to 3 times this in height. Again, rotor diameter is going out to 85, 90 metres, so 3 times that diameter. Pretty big babies when you think about it. What you can't see at the back of the nacelle, the square box at the top, are the measurement indicators, but we've got an anemometer measuring wind speed and like a weather vane, a wind direction indicator, which together feed the signal back to the base of the tower there. You can see the locked off door there where the engineers can go in. Just right behind that are the computers that control the response of the turbine, and that determines the direction in which the nacelle and the rotors face and the pitch of the blades. That's all controlled automatically. The turbine runs freely. We don't turn it on and off apart from maintenance or anything like that. It runs freely, so it self-starts when the wind speed gets up to something like 3.5 to 4 meters per second, say 7 to 8 miles per hour in old money. It'll start generating, not an awful lot to start with, but as the wind speed carries on increasing, hopefully, the output of the turbine goes up until you get peak output, in this case just 225 kilowatts, when you have a wind speed of 15 meters per second, 32 miles per hour. The system then self-controls and keeps that peak output as wind speed gets stronger, and if you get a wind speed in excess of 25 meters per second, say 53, 54 miles per hour, at that point it will shut itself down automatically. Feathers the blades so they come just parallel with the line of the wind, which itself will stop the rotor very quickly because that's the line of least resistance to the wind, obviously. And there's also a mechanical brake which can be clamped on around the hub to stop any risk of rotation. So all that happens automatically. As soon as the wind speed drops, brake comes off, the blades pick up their normal pitch and they start to rotate again. So this idea of shutting down turbines in high wind conditions, and I've seen that said, oh, turbines are useless because they shut down at the time you want them. They're certainly far from useless. They're smart enough to shut down at just those very peak times when the design limit of the turbine is met. You know, if you're going to be in a constantly stormy condition, you upgrade the design spec to cope with that. But of course that comes at a price. It means it's not going to be so efficient at lower wind speeds. So you choose the turbine for the circumstances, and then it looks after itself very efficiently. And the periods of shutdown are just while those peak winds are there, which is usually only a few minutes or perhaps a few hours. Okay, I think we spoke a fair bit about turbines inside, so I won't spend any more time on it. You can just see a little bit of the construction of the tower there. Bear in mind those sections of a turbine tower have to be taken on the site by transporters, either by road or by water if that's possible, occasionally by helicopter. And then also the nacelle has to be brought in place. Oh, we've got birds frisking there. Gosh, yeah. Fun, yeah. I don't know, anybody recognise a bird? I'm not sure what it is.